All right, I won't say I'm making progress on this. Basically, when you start a project and you finish it, they're the best moments. In between is when you curse yourself and say, why did I ever buy this? Why did I ever start this? But here's that flower pot, and you can see I ground it around the top, and this ring fell off. I've gotten really good at it. I've done over 50 of these, and there's a lip in here where this will set in, and you drill a hole on the opposite end right alongside it, and this is mica. If you don't get it under the bottom of it, it'll come up in layers. Okay, so you want to drill a little hole and then pry it up with a sewing needle or some type of pick, and now you can see there's the 3 leads. You cut them off. Below here, you leave a piece underneath the terminal, and the reason you leave it, see there's 3 long leads on here, or leads. When you heat this up, see I put this in a vise and then I pull from behind here, but first I also clean the wires off the terminals, and then I run a small drill through these, and then the capacitor goes up through the terminal, and then you solder them, and then you clip them off. Okay, that's how they're originally done. And down in here you see the first. This is an insulator. You peel this off, and there's your beeswax. It's not oil, it's beeswax. Okay, now if you heat this up, I use a heat gun. You can use a hair dryer. That beeswax flows right out of there, and then you have to unsolder from here and pull. You're going to have this in a vise or someone help you hold it, but that's done. Okay, I'm working on that in between. Now I also want to tell you, I took this apart. This is the crystal oscillator. Now you might see guys saying, oh, it's in an oven, there's an oven in there. No, there isn't. See, I took it apart. There's a big honking crystal. That's a crystal. Okay, if you take that apart, there's 2 screws on the top. You'll find a disc of quartz crystal, of quartz rock, a very thin piece, and it'll be plated on both sides. Sometimes there's springs in there that make contact to the plated sides, and the oscillator, this actually vibrates. That little piece of quartz actually vibrates. Now this is what they started looking right after World War II. This is also surplus. Now you could rewire the socket that takes this crystal so you can fit the oscillator, the crystal in like that. Okay, I'm just telling you. And then say this is 3580. That's 3.58 megahertz, or 3.58 kilohertz. In the old days, they call them kilohertz. This is actually marked kilohertz. This is marked kilohertz on the side. I don't know if you can actually see it. Right here. 350 kilohertz. That's the old days. All right, but kilocycles. Oh, now I'm messing up. Well, anyway, the old days was kilocycles, became kilohertz. They named it after the guy Hertz. Look it up. But you could do this. All right, now what happens if you do that? This is not run. If you stick that in there, you got to rewire it though. You have to bring a jumper wire. One of these is ground, and one of them's the hot side of the crystal that goes up to the oscillator. Now, when you put this in, this does not control the frequency of the oscillator. What it will do is, when the front dial is turned to this frequency, this magic eye tube will close up. Okay? This front dial is a VFO. You can set it between any frequency from 3 megahertz to 4 megahertz. All right, it's continuous. You could put a crystal in here and then set it up with the eye, and now you know the radio is calibrated for that frequency. Okay, the FCC really doesn't want that. FCC, for a novice, it wants, when you put a crystal in this radio, it actually controls the oscillator. Okay, that's what you have to understand. It's one of the many things you're going to have to understand if you think you're going to convert one of these command transmitters to a novice set. Now all this information is found in different conversion articles. CQ magazine, you have to do a little bit of searching and you'll find different reprints. And I found them all and I read, but I had seen a guy say, it's an oven crystal. Now it is pretty fancy. Now, there's actually a spider web in there. This is steel, and what happens is steel holds its temperature pretty good. So this thing's in a cabinet, so the temperature on this crystal stays fairly constant. It doesn't quickly change. And within that time, you tune up the transmitter, and then the receiver on the other end is pretty wide, so there's no problem. And then the other guy on the other side, he can adjust his receiver. It's not like modern things where it's digital, and you really can't tune certain things. But I took this apart just to show you. There's a large crystal in here, and there is no oven. Okay? There's only 2 connections. An oven would have 4 or 3. Okay? There's another. No, there's an oven in there. And it's got this nice little top, so you can pull it out. Okay? And you could calibrate the dial. Set this radio up if you had one for 3 megacycles and for 4. You could plug it in here, use the eye, and set up your VFO oscillator. Okay, there's many ways, but I wanted to show you today. There is no oil inside; it's beeswax. Okay, and you heat it up and it flows out, and then you have the wires and the tin foil in there. You got to gut it. Got to unsolder the leads from there, and then when you put your capacitors in there, you tie 2 of them to the other 2 capacitors to one lead, one side of them, and then solder it. So you only have one lead coming out of the bottom of the capacitor, and the other one's going up to the terminals. Okay, you don't try putting all three leads through the bottom of the capacitor. You could widen the hole, and you could do it that way, but that's how I've been doing it. And after you do enough of these, you go around nice and neat, all of a sudden this ring cracks off. And this is the rolled over piece of metal that held the mica in, okay? And that's why the guys, if you go look at different internet website, guys use, they cut this in half in the middle here with a pipe cutter, or he put it on a lathe. See, if you put it in a lathe and just hit this, he could cut, it would have been, I don't know. I just don't know about other people anymore. I have a certain way of doing everything. I think things through before I do it. I do a test, then I do it. People actually do the test to see if the glue actually works on the actual thing they're trying to glue. And they make a mess, and then they give up, they put it on eBay, and then I don't see it in the pictures, and then I end up buying it. But as you see, this capacitor came off. There's three bolts. I had to unsolder, and then that capacitor's off, and then I can re-oil it before it goes back on. Now, I sent away for some those 4-sided Bristol wrenches. They're called spline Bristol, whatever. They're called. Some people call them 4-fluted, 4-splined, but they still use the name Bristol, and that's the company that I used when I was in aerospace. And I ordered from eBay, and there's a set of Bristol 4-sided, 4-fluted, whatever you want to call them. They're for Hammerland, and a few other radios have them in it. Collins radios. And what I've been doing is I grind down a piece of metal to fit the set screw. But I got so many set screws on this unit. I'm like, I just ordered a set of wrenches. It's just so much easier. And in the future, if I do any more, I won't have to suffer, you know, because when you make your own tool, it works a little bit for a while, and you got to harden it. And there's a big process to making an Allen key or a spline Bristol. So I decided to order, but there is no oven in this thing. Okay, get a lot of that. See, on the different conferences, people shoot from the hip. They see an oven or heard about an oven. And ARC Tech, my instructor, he mentioned ovens, crystal oven. And I have a crystal oven for an R71A crystal. And what's inside is a a thermistor that heats up. And when it gets to a certain temperature, its resistance goes up. So then it is not generating as much heat, starts to cool down, it comes back down. So rather than use a thermostat in the old crystal ovens, they had a crystal in there, they had a winding in there of nichrome wire on a piece of porcelain, and then a little thermostat that kicked on and off. And it would keep the inside of the crystal a certain temperature, the chassis or the box. And that would keep the crystal at the same temperature. See, crystals, they are very accurate, but they do drift with temperature a little bit. So if you really want a super duper something, you basically want to have an oven. Now I could show you something if I can find it. Sometimes I have to fight with stuff. Okay, I found it. All right, now, you see that little, looks like an IC chip, don't it? It says 3 volts on it. I put it on this so I can put it in proto board. When you put 3 volts across this, it puts out 10 megahertz. 1 part per year. In other words, it's within 1 cycle per year. And you say that's impossible. It's not. This has an oven in it. You have to heat this thing up. It's got 3 leads. Okay, it's got a ground, a heater voltage to keep this warm, and then the output of 10 megacycles. And what this is for is calibration. This is the quick way I can calibrate a frequency meter, a frequency counter, because this is a standard. This is off 1 cycle per year. Actually, it's better than that, but I know so. Oh, it can't be that good. I never. Yeah, you can buy these things. I think it was like $9. But this is a reference. You know, I could have built a big fancy box with a lot of lights and switches on it. And look, oh look, I built this calibrator. There it is. This is my calibrator. When I need it, I plug it in a proto solderless breadboard, apply some voltage to it, and then I set my test equipment up or my scope. I can actually calibrate a scope with that. Okay, that's my calibration. Okay, and you're gonna say, "Whoa, you can do it." I told you when I was in RCA, I was put in charge of calibration. And to get started, it was really aggravating. The engineer was left. His name was Ken Recor. And he showed me he used the 60 cycle line to start. And the audio generators, it's good enough. Okay? And you use Lissajous pattern. Look it up. And when the frequencies are equal, they form a circle on the scope. And then if it's double the frequency, you get 2 humps. Look up Lissajous patterns, okay? and I knew how to do that. And he was just teasing me the whole time. He goes, believe it or not, he goes, I know you know how to do this. So he says, put 60 cycles into like the vertical of the scope, and then you put your oscillator that you're calibrating in the other side, and then you start at 120. You put a double frequency into the 60 to get 2 humps. That's 120, and if that on a audio generator is good, the generator is basically going to be good. Okay, and then you can go up in frequency, and then like HPs, some of the HP ones are really accurate. And that's how I also calibrated my HP using the Lissajous pattern. I think that's it. All right, that's it.